everybody, my name is Shoreline Martinez. I am a senior here at USM, majoring in ocean engineering, and today I will be presenting my PhD project, which is called Living Shoreline. So my decision on what to make for this project was for a coastal erosion project, where I could potentially research on how erosion can be controlled by using gabion baskets. This decision arose because at the Marine Educational Center in Ocean Springs, Mississippi, they were going through fixing one of the buildings which was having an erosion problem, which we will get into in the next slide. And I just decided that I could potentially create a model in where they could see how the gabion baskets could potentially help this erosion. So a little bit of more information about the MEC. So the erosion is caused mainly by the runoff of water of the building. Here in the bottom two pictures, you can see how that erosion is happening. Now, with this runoff water, the waves caused by oncoming boat traffic by the bayou also had an effect in this erosion because of the sediment type. For this project, they have scheduled meetings at the end of each month, and I was able to attend most of them. And the estimated time for this project to be finished is July 2025, and they started it August 2024. So what are gabion baskets? These are wire mesh box containers, which you can fill with an earthy material. In this case, it's going to be, I use rocks. These allow water to flow through while holding back the sediment in that area. And over time, marine organisms can colonize the surface, which makes the baskets more eco-friendly for the environment. And these can also be adjusted with the landscape. So the project at the MEC, as you can see here in this bottom picture, this is a building that is being affected by erosion in the bayou, and right here you can see where the aerial view shows the boxes where they're going to be placed and what is going to be filled with the sand. So a little time lapse of my project. Last semester I was able to work on the onboard, the review, and the engineering plans. Now these engineering plans did come over to this semester, at least for the start of it. And then this semester I also did the conclusions, the calculations, the conclusion, and the model. And then all throughout the semester, I worked on my project paperwork, where I was able to keep track of everything that I did for my project, thanks to this class, which helped me maintain a specific set of notes every week, where I could present it and potentially combine all of that for my final report. So motivations and standards. I was motivated by the idea of creating something that could potentially have a positive impact for natural landscapes. I have a very strong interest in developing practical engineering-based solutions to address environmental changes once I graduate, and this basically allowed me to have a hands-on experience on creating a new environmentally friendly way to help different buildings around a coastal area. And some of the standards that I made sure to include for my project are these down here: the ASTM A974 and the engineering manual. So I decided to build a model in which I can show how erosion can be controlled using gabion baskets. These are the first rough sketches that I created in order to start the visualization, because it's not the same me trying to tell somebody how I visualize it than have them see it on a piece of paper. And as I kept researching this, the sketch and visualization changed for my project. So this is at the beginning of the semester. You can see the dimensions here. It's a very rough sketch. And then after that, I was able to create the official technical drawing. This ended up being the final one. All of the dimensions shown in this slides are in feet. The paddle was designed for the flat vertical face to generate wave motions when oscillating efficiently. The shape and size were optimized to fit the enclosure while maximizing wave energy transfer. The paddle is connected to a rotating arm that allows controlled back and forth movements around a pivot point, which is this area right here. And the paddle pivots at the bottom of the enclosure to simulate how waves behave as they transition from deep water waves to shallow water waves, which we know as shoreline. So to better understand how the paddle in my model generates waves, we can apply the linear wave theory. This theory allows us to predict the wave characteristics such as height, length, and the period based on the motion of the boundary like the paddle. In my case, the paddle is designed to oscillate at a frequency of around 1 Hertz, which simulates the wave behavior observed in a nearshore environment. Using this theory, it helps ensure that the waves produced in the tank are realistic and follow the correct transitions. My ratio for this one was a 1 to 10. And here is the equation that I was able to use, which is the height of the wave over the stroke length. And then following that, I was able to calculate my paddle as a physical pendulum. So in this slide, we can see the equations that I used in order to calculate the moment of inertia for each steel pipe in the physical pendulum. Since all of the pipes, are cylindrical and rotate about different axes, I had to use 3 different equations for the steel rods. First, I used the cylinder one, where it rotates around its middle axis. Then I used the solid cylinder, which as well it rotates around the middle axis. And then lastly, the solid cylinder, which rotates along its one of its end axis. So in order to calculate the frequency for this paddle, I had to add up all of the moment of inertia for the steel rods, the connectors, the paddles, and the weight. And I added them up and plugged them into this equation, which is frequency equals 1 over 2 pi and the square root of the total mass of the system times the gravitational constant times the distance from the center of the gravity to the pivot point over the moment of inertia of the whole system. So this slide shows the results of my MATLAB script that shows how the length of the pendulum affects its natural frequency. As you can see here in this graph, there is an inverse relationship, which is that while the length increases, the frequency decreases. This follows a theoretical formula for a simple pendulum where frequency is proportional to the square root of gravity over the moment of inertia. So although my project uses a physical pendulum, this trend still applies and helps explain the tuning the length of the bottom part of my paddle. So now going into my model, here we can see the main components of my physical model. The container holds the entire setup and provides a controlled environment for the wave testing. The stand in this area is placed at this end to replicate the bayou bed and erosion. Then we have the paddle right here, which is mounted on the pivot and acts as the wave generator, which it creates approximately a 3-inch wave. Then we have the gabion baskets on this side right here, which are positioned in front of the stand to reduce the wave impact and to prevent the erosion. And finally, I decided to include an acrylic sheet to the side of this to allow visual observations of the wave movement and sediment interactions during the testing. And here is also showing my paddle. So now to the building process. Here I decided to include some pictures of my process. Here is when I was able to get some of my plywood, which I ordered through the school, and some I ordered face to face. I was able to get help cutting them precisely, then at my house working it, taking everything home, starting to the installation of the acrylic on the plywood. Examples of the gabion baskets that I created around 25 of these. Then this is a reminder to be safe around resin, make sure to wear gloves. Then this is how my model was starting to create after we put all of the pivots in place. Then this is the coating it with the first layer of resin, and then this is the first layer of the plexio. So next, we have the materials. I am going to be breaking it down for every section. So for the model itself, we have the plywood, which is used for basically the skeleton of the model. Then we have the wood screws and the wood glue, which helped me put it all together. Then after that, I sanded it down and applied a fiberglass tape to the seals to make sure that could act as a barrier for leakage. Then I also went in with the resin and to add a more waterproof coat, and then finally with Flex Seal to seal everything in and add more waterproof protection. Then for the paddle, I decided to use the steel rods. Then we have the mounting bearings, and then the connectors. And then for the testing area, we have the acrylic, the sand, and the gabion baskets with little pebbles. So the budget estimate for this project, it was around $463.88. This project was made possible through the support of the Eagle Spur grant and the OEP&D funding, which allowed me to purchase the materials needed to build and test my model. So following, I ran some tank simulations to see how gabion baskets would help the erosion control and what would happen without. And over here, as you can see, the absence of gabion baskets allowed the wave energy to directly impact the sand, causing a slope failure right here. Here I can. This definitely highlights the importance of a shoreline protection, in which measures its in mitigation of erosion under control wave exposures. And here you can see how the bottom is like caving in shoreline. And you can definitely see all the sediment transporting right here. So you can see how murky the water is. Alright, so next is the final product. After I set everything up, this is how it looked holding the gabion baskets. Here I included a video of how the paddle moves, how it looks, and here's an image of, the paddle from the side. Then here I made sure to include a video in which you can see the waves impacting the gabion baskets. And as you can see, definitely less sediment in the water. And then lastly, I decided to add a video showing how the water moves through the baskets. So some adjustments and problems that I faced through the building process in all of both the semesters was one of them. I definitely recommend that if you are going to build something, go over the budget that you think you're going to use, because I definitely went under when requesting funding, which then I had to put some of my own money. Despite the challenges of the construction, I was able to adapt. I definitely faced a lot of challenges when it came to the actual measurement parts, but it's just something that you like need to think fast in the moment and adapt to it. Determining the panel dimensions through coding. Coding is not one of my strong suits, so that took a little while. So that definitely delayed my mounting process for a bit. Then improving communications through with the people that are working with you. I would definitely recommend meeting bi-weekly or something like that. That could definitely help the project. And deciding which materials would be best for my building process. There are definitely thousands of materials out there that you can use. And deciding which ones to use is definitely one of the hardest parts. And then doing your research about how you're gonna actually start building it is definitely a hard part, because you see all these different people doing different designs, and it's kind of hard to see which one would definitely fit more into your project. So the aspirational goals, this project definitely could be a foundation for future researchers. I aspire to apply this concept to a waterway channel behind my house, which this project actually started with, thinking about applying that to my house, but it ended up being a model. I would definitely try to do that, as it is low cost in comparison to other ways in which can potentially damage the environment. Now the documentation and results, I will be donating this model to the MEC, since they can definitely use that as a learning tool for students that are going to be on their summer programs, and they can definitely use that and say, like, here's how gabion passes works, here's why we implemented it, and this is how it will definitely help. And then for future OE USM students, if you're interested in building on my project for your senior work, feel free to do so. You can contact me. Dr. Nunes has all my information, and yeah, they can. I would be glad to help. So conclusion and references. This project gave me a hands-on experience in both technical and personal growth. I developed better skills in 3D modeling and fusion, wave theory, and physical prototyping. And I also improved in my management, time management, and problem solving. One key realization was how much time and precision it takes to build a system and a model. So that definitely helped me develop my skills for the future. Any questions? Yes.
Is there any reason that you have the water level where it is, or have you thought about making it more full so you can see like larger waves?
I definitely thought about that. I did not want to fill it up all the way, because it was more of a scaling thing. If that makes sense? Because the gabion passes were 1 to 10, so I also wanted to incorporate that to the waves. But it can definitely, like, if you go right now, you can definitely add like 5 more gallons to it, and it'll hold because it's leakage proof.
So you can still keep that 1 to 10 ratio for your wave height, but if you had like a slightly higher water elevation,
Okay.
it'd be interesting to see the difference in how they react with the gabion baskets. So in the same wave height.
Did you ever go to the project consider automating the wave motion, like using a kind of like what Martha and I did, like a wave flume, something where you could input wave parameters?
At the beginning, I did, but since coding is not one of my strong suits, I did not want to implement that, knowing that it would cost me so much of a hard process for me to like get like acclimated with it and then potentially do it. But it can definitely be done, just at a smaller scale, because it would definitely cost more if I decided to implement something that like what she has.
You showed the graph of the mathematical or ideal pendulum or simple pendulum. How does this relate to the physical pendulum you actually used at the end? Did your pendulum end up having a natural frequency similar to what you wanted, or
My
was low?
pendulum, I have not set it up yet because the bearings that I was going to be using were the parts that was gonna actually help it with the motion. My bearings ended up being the wrong size that they were ordered. So I had to, I wouldn't say create, but like maneuver and like decide. I go back here. Oh. Here you can see how it's really a piece of rod that's in there, and then the steel pipe goes through it, which it does not help with like the motion part of it. It creates too much friction from my point of view.
Also, if you go to the slide where you show the various moment of inertias, one before, I think. Yeah, the solid axial cylinder. Where was that used?
That was for the weights.
For the weights. Okay. I don't think you had it. You didn't show your weights, right? Did you show weight?
No.
All right.
Y'all want to go outside and
We absolutely should. Any more questions? All right, take us to it. I will walk with something here.
What's those little skateboard tech? Dude, that's what I was trying to think of.
I was thinking the same shit.
how it looks like.
Oh, we kind of did it backwards.
You're gonna want to move it away from the wall a little bit.
Because I don't have the bearings,
Well, now it's got
it was
like an
just
extra 50
easier
pounds.
to actually just like have it up here.
Yeah, take it away from the wall so we don't get the permanent mark there.
Thank you. Because I don't have the bearings, I decided to just put this up here so it'll be easier until we get the bearings. But it definitely, you can see, it only has like 5 gallons of water now. And it will create the waves.
Are you gonna do the little like stomper things?
Someday. And from the side you can, I think you can see how it looks. But yeah. This is
I like your decoration.
Thank you.